All right, welcome back, everybody. We've been talking about EIGRP, the routing protocol. Obviously, everything that it does is features. We've configured basically or basic configurations of EIGRP, and we've looked at the topology table and even looked at the routing table. So one of the things that I pointed out in the topology table was the feasible distance and how it's going to calculate the metrics. All right, so this is one of the things that we're going to talk about now. Oh, I forgot I did that. Okay. So we need to know a couple terms. Now, I'm not going to kill you all these terms, but you do need to know. I'll tell you which ones you actually do need to know because you may be asked in a question. Okay. The first is the reported or advertised distance. Now, I'm going to back this up in the next slide with a little drawing that I did. Okay. And then we're going to go right into I'll go into our lab, which I kind of changed a little bit. And we'll see how that works. I'll show you the topology table and where these numbers are at. But the reported or advertised distance. Now, this is the metric that's being advertised by your neighbor. So your neighbor is advertising to you, hey, to get to this network, this is how much it's going to cost you. That's the little metric right there, okay? And it's also is the second number in the topology table. All right, so in the topology table, you have your parentheses, and there's two numbers. The second number is that advertised distance from your neighbor. The feasible distance, this is important, is the best metric all paths to a remote network. So the lowest feasible distance is the one that makes it to the routing table. Okay, and that's what it says right here. Lowest FD makes it to a routing table. So that's important. So when you're looking at the topology table, you see the feasible distance. That is the one that it calculated. And how does it calculate? We're going to learn that in a second. All right. That's the one that it tells you, hey, this is the way we're going to go. And that's why it makes it to the routing table. All right. Now, the neighbor table, and we talked about that as well, it's information about your neighbors. What does it tell you? Well, it tells you the IP address of your neighbor. It tells you how long it's going to hold that information, the smooth round trip timer, and the queue. And remember, as far as what you need to know about your neighbor, yeah, okay, the IP address, the whole time it is important. It's a default 5 seconds. Or the hellos are because it maintains that neighbor relationship with your neighbor every 5 seconds. And the reason that it doesn't need to be the same is because it doesn't need to tell all the routers. It's just going to make them aware, hey, this was going on. So that's why your hellos don't need to be the same. All right, but that's why you got the hold down timers that you can actually tweak and can hold the information longer, because that tells the router the hold down timer. And that's one of the things that you may get asked. All right, was the hold down timer, what happens when it expires? Well, then it tells your routers, your neighboring routers, hey, to get to this particular network, yeah, it's dead. It doesn't exist anymore. All right, so that's what that's for. Now, the topology table is populated by the neighbor table and obviously using the dual algorithm when it calculates this metric. All right, so it's a combination of both, and we know already that it holds all the routes to the entire all the remote networks are there, and the successor route that's in the topology table gets copied into the routing table. All right, the feasible successor, that's the guy who came in second place. Now, I'm going to read this verbatim. Path whose advertised distance, because this could be a question, I don't know. Path whose advertised distance is less than the feasible distance of the current successor and considered a backup route. EIGRP can keep up to 32 feasible successors and probably more. Okay, and probably more. It can hold a lot more now with the newer iOSs, but hey, 32 feasible successors, I think that's quite a bit. All right, but what you need to pay attention is this first sentence. Path whose advertised distance is less than the feasible distance of the current successor, okay? Who's lower, okay? Or the current is advertised distance less than the feasible distance of the current successor. So that's the guy basically in second place. That's the one that's going to stay in the topology table. That is the backup route in case the successor route, which is the best route to the network, okay, to the remote networks, makes it to a routing table. It's the backup for that. So if the successor route fails, Remember, I said this already. When we looked at the topology table, it will query it, and hopefully you'll have a feasible successor that can grab that information from. Okay, so we have this terminology, and this information will be available to you. All right, so you don't have to, oh my God, he's in the way, I can't see. It's going to be there for you, so you'll be able to look at it, download it, what have you. But we need to know is, how do these numbers come about? Okay, and basically, I drew this just so you know it's a network, and this is a remote network over here. But you have 3 routers, okay? And you can see I put it here, okay? The advertised distance, meaning this neighbor is advertising to get to this remote network, okay? It takes it 1,000. So it's telling, hey, you want to get to this network, it's going to cost you 1,000. All right. And to get to this network in Florida, right, or through Florida, is going to cost you 1,500. So this guy over here is saying, I want to get to that network, but which way do I go? So what is it that I do? Okay, very simple. Okay, you're going to come here. If I can, there you go. Get the pen out. So you're going to say, okay, if I go through California, what happens? Well, I'm going to take that 1,000 that my neighbor is advertising to me. That is the advertised distance, not the administrative distance, but the advertised distance, plus my metric to get to California, which is 500. Right? I add, that is a plus symbol. I add those two, I get 1,500. So that means the feasible distance, right? That gives me a feasible distance to get to that network right there. So through here, if I go through California to get over here, that's going to cost me 1,500. Okay, not a problem. Now we know. All right, now let's do Florida. Let's calculate Florida. No problem. Florida is 1,500 to begin with. That's the advertised distance right there. So Florida, 1,500 is the advertised distance, right? That's what Florida is saying. Hey, you want to get over here, it's going to cost you 1,500. And for me, it's the same, 500. So if I add those two, let me see if I can make a better plus so you guys don't laugh at me. There you go. All right. It's going to be 2,000. Well, it's going to cost me more to get to this network if I go down this way. So then that feasible distance over here is bigger than California, because California was 1,500. So it's going to choose based on the feasible distance, which is the best path to the network, the remote network, which you just went over the terminology. So I'm going to go the other way. But since we have 2 paths, this could be a feasible successor. Okay, could be a feasible successor. All right, but we'll see this now in the lab. So this is how the math works. No big deal, right? The advertised distance from your neighbor plus your own metric, okay? You add those two, you get the feasible distance. That's all it is. And if we look at it here, let me escape out of here. All right, and let's bring up router 1. And you can see I added a network here. This is the 2.0 network. I already added it to router EIGRP 130, so it's being advertised. All right, and the same here. So we go to router 1, and let's maximize it. And let's do enable, and let's do a show IP EIGRP topology. Okay, boom, 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 boom. Let's get it all out there. All right, so we do the EIGRP topology, and the 200 network, or the 2 network, I should say, the 2 network, if you look at it down here, you see the feasible distance is that number right there, 217.4976. Now, I know you're supposed to say it's the lower metric. It's the lower metric. But this is the feasible distance. That guy right there. And it's this one, 217.4976. All right, but why is that, you should say, well, man, shouldn't I choose this? Because let's take a look at our routing table. Let's make a comparison. See who will be the successor route to the two network. And see, and it chooses, you got two ways to get there, right? Through the 10, which is the fast Ethernet, or through the 10115. Now it's like, well, what? But look at the feasible distance number. That 37160 that we saw in the topology table, okay, if we scroll down, that 30720 that we saw, it's not going to come into play. It's not going to come into play at all because the feasible distance is this number that we're looking at, and is the feasible distance that is the best path. Well, Laz, how can that be the best path if the other number is lower? Well, let's take a look to see exactly which way it's going to go. Or not from there, sorry. Let's do this again. Come here. From here, we want to go here. And let's go ahead and auto capture play. And it's choosing to go to the 10, down to the serial, and then that way. So that's the way it's choosing to go. And that's the way that we looked at it when we saw it in the routing table. All right. That was going to choose via the 10 network right here. Yeah. All right. Because of the feasible distance. So based on these numbers, based on these metrics, the key thing to look at when you're looking at the topology table is the feasible distance, because the feasible distance, by its definition, is the best path to the network. Always keep that in mind. All right. Now you know the math. Now you know how to figure it out. It's just a matter of practice, practice, practice. Now also keep this in mind. You don't want to have too many feasible distance or many feasible successors, I should say, because if you have too many feasible successors, it could be, and again, this is out of the scope of the CCNA, you could run into a routing loop issue. But again, it's beyond the scope. But you should have at least, like the number states, up to 32 feasible successors. Have 1, 2, or 3 backup paths that if one fails, the other one can just query its own topology table and put it in there so you won't lose communications. I'll see you in the next one.